is investigation of the accuracy of a lathe. The purpose of the work, study of the accuracy of the lathe, which may affect the occurrence of machining errors. Equipment, instrument, and accessories that we need in our practical lesson. First, screw cutting lathe model 1M61P. Indicator. 3. The mandrel is cylindrical or cylindrical mandrel. Arbor with ball center hole. And fifth, the indicator stand in magnetic. So have you finished this equipment and purpose of the work study?
Yes.
Okay, next slide. And there are general view of the screw cutting lathing machine. And what is lathe? Let's see the video about lathe.
Welcome to Academic Game Tutorials. Along with the operation of different parts that together
Construction, details,
machine.
and operation of lathe machine.
We need to know what a lathe machine is. A lathe machine is a machine tool that is used to remove metals from a workpiece to give it a desired shape and size. So, the function of lathe is to remove the metal from a workpiece in the form of chips by mounting the workpiece rigidly on a machine spindle and revolving at the required speed, and the cutting tool is fed against the work either longitudinally or crosswise to make the work to the required shape and size. Now, let's look at the construction details of a lathe machine and the operation of different parts that together construct a lathe machine. First of all, we have the stands, or legs, in a lathe machine. This is used in holding the lathe machine and in elevating the lathe bed to a working height. Legs are the most bottom portion and carrying the entire load of a lathe machine tool. The legs are firmly secured to the floor by the foundation bolt. The legs or stand of lathe machine is made of cast iron through the casting process. Since cast iron has a high shock absorbance and wear resistance capacity, so it helps the legs to absorb the vibration during work and transfer to the ground. Above the legs, there is a tray. This is also known as chip stand. It is placed at the lower side of bed and above the leg of lathe machine. The main function of chip span or tray is to collect or carry all hot chips removed from the workpiece during machining operation. Above the tray, there is the bed of the lathe machine. It is also called the lathe bed. The bed of a lathe machine is the base on which all other parts of lathe are mounted. It is massive and rigid single-piece casting made to support other active parts of lathe machine. The bed is chosen according to lathe machine specification and requirement. It is usually made by single-piece casting of semi-steel or chilled cast iron due to its high compressive strength, shock absorbance, and high lubrication quality. If we are making a larger lathe machine, then 2 or 3 pieces of the bed are casted and then bolted together. And for comparatively smaller general-purpose lathes, the lathe bed is made through single-piece casting at a time. There are guideways on the lathe bed. These guideways take care of movement of tailstock and carriage on bed. On the bed, there is the feed box. This feed box is connected to the lead screw and the feed rod. The lead screw is an externally threaded shaft or rod. It converts rotational motion to linear motion. Lead screw is used for thread cutting operation in a lathe machine tool. The lead screw is used to move the carriage automatically during thread cutting. The feed rod is a cylindrical rod. It does not have any thread on its external surface. This feed rod is used to move the carriage from the left side to the right side and also from the right side to the left side. Now, on left end of the bed, Headstock of lathe machine is located while on right side tailstock is located. Headstock is situated at the left side of the lathe bed and it is the house of the driving mechanism and electrical mechanism of a lathe machine tool. Headstock transmit power from the spindle to the feed rod, lead screw and thread cutting mechanism. There are speed selectors for controlling gear speed. And here, we have a lever called the driving clutch, which is used to engage and disengage the spindle from the gear mechanism inside the headstock. In other words, it engages and disengages the motion. At the starting of the lathe, this driving clutch keeps the motion disengaged from the spindle, and then when we need we can use this clutch to engage the spindle with gears for motion, and the spindle starts rotating. Here this is the spindle connected to the headstock. The spindle possesses lever center to which the workpiece can be attached. There is a hole throughout spindle for handling long bar of workpiece. The spindle is hollow inside, and has threads cut on the external surface. On the other hand, the chuck has threads cut on the internal diameter. So, the external thread on the spindle surface and internal thread of the chuck results in coupling or fitting of the chuck with the spindle, just like nut and bolt. After mounting properly, the chuck and the spindle becomes an assembly. The chuck here is used to hold the job or workpiece firmly during the machining operation. As we have just discussed, it is mounted on the spindle which rotates the chuck and workpiece. Depending on requirements, we usually use two types of chuck, 3-jaw chuck and 4-jaw chuck. The 3-jaw chuck is also called universal chuck because the 3 jaws move simultaneously when any one jaw is adjusted. These 3-jaw chucks are generally used to hold cylindrical jobs. The 4-jaw chuck is also called independent chuck because in 4-jaw chuck each stepped jaw is independently operated by a different screw. So, the 4-jaw chucks can also hold the square jobs rather than cylindrical. The tailstock is situated on the right side above the lathe bed. It is made out of cast iron. The tailstock moves on the guideways on the bed surface, and it can be moved forward and backward, towards and away from the chuck according to requirement and job length. The tailstock is used for supporting the long end of the job for holding and minimizes its vibration and sagging, so that the long workpiece or long job does not deflect or bend during the machining operation. It holds the tool for performing different operations like drilling, reaming, tapping, etc. and it is also used for a small amount of taper for a long job by offsetting the tailstock. This tip portion of the tailstock is also called the dead center because it just provides support and no motion is provided to this point. Similarly, on this side, we provide motion to the spindle, which in turn rotates the chuck and workpiece, so this is called lever center. Both lever and dead centers have 60 degrees conical points to fit center holes in the circular job, the other end tapering to allow for good fitting into the spindles. The dead center can be mounted in ball bearing so that it rotates with the job, avoiding friction of the job with dead center as it is important to hold heavy jobs. In the tailstock assembly, we also have the ram clamp and the hand wheel. When we rotate this hand traversing wheel, this dead center moves back and forth. That is, when this hand wheel is rotated, the dead center moves in and out. The ram clamp is used to apply lock on this movement of dead center. So this ram clamp locks the dead center in the tailstock, so it does not move. In addition to this, there is also a tailstock lock, which is used for locking the tailstock firmly in place according to our requirement during machining operation. On the left of the headstock, there is the main driving pulley and gear system. This driving pulley system is connected to the gearbox inside the headstock. This driving pulley is connected to the motor through belt. Then comes the carriage. The carriage is used for support, guide and feed the tool against the job when the machining is done. The carriage holds, moves and controls the cutting tool. It gives rigid supports to the tool during operations. It transfers power from feed rod to cutting tool through apron mechanism for longitudinal cross feeding. Carriage simplifies the thread cutting operation with the help of lead screw and half nut mechanism. The carriage is formed of 5 parts: saddle, cross slide, compound rest, tool post, and apron. On the carriage there is a hand traversing wheel. Using this wheel we can move the carriage left or right along the feed rod and lead screw. There is a half nut or screw cutting engage lever on the carriage. This half nut is used to connect motion to the carriage automatically. If the half nut lever is engaged, it engages the carriage with the lead screw, which results in automatic movement of carriage right and left by being guided by the threaded lead screw. Thus, the split half nut is used for automatic feed instead of providing manual feed, which helps us to cut thread with accuracy. Mounted on the carriage there is a saddle. Generally, the saddle is made up of H-shaped casting and it has a V-guide and a flat guide for mounting it on the lathe bed guideways. The cross-slide hand wheel is assembled on the saddle. The cross-slide generally travels at right angles to the spindle axis. That is, let's take for reference, if this hand-traversing wheel moves the carriage left and right, then this cross-slide wheel moves the saddle towards front and back, that is perpendicular to the bed. So, since the cross-slide hand wheel gives cross movement or perpendicular movement, so it is called cross-slide. Above this cross-slide and saddle, there are compound rest mounted above them. The compound rest supports the tool post and cutting tool in its various positions. It can be swiveled at any desired position in the horizontal plane. Compound rest is necessary for turning angles and boring short tapers. It can rotate and fix to any desired angle. The compound rest slide is actuated by a screw, which rotates in a nut fixed to the saddle. Then, above the compound rest, the tool post is mounted. The tool post is an important part of carriage, which fits in a T-slot in the compound rest and holds the tool holder in place by the tool post screw. It is the topmost portion of the carriage and it is used to hold various cutting tools or tool holders. Generally, the single-point cutting tool is mounted on this tool post. The last part of the carriage is the apron. This whole portion is called the apron. The apron is fitted to the saddle. It contains gears and clutches to transmit motion from the feed rod to the carriage, and the half nut which engages with the lead screw during cutting threads. Apron acts as a cover or housing for all the mechanisms inside the carriage. Below the lathe bed, there is an oil sump. This oil sump is a place where the machine oil from different parts, especially the machine oil from the shaft, is deposited in the oil sump. In the bottom portion on the leg of the lathe machine, there is also space which can be used as storage for gears, chucks, tools, etc. And also this space is used as a housing for motor mechanism in some lathe machine. So, we have learnt the construction details of a lathe machine, along with the detailed operation of different parts. If this video was helpful, subscribe to Academic Gain Tutorials on YouTube for more updated videos. Thank you.
So now you know the construction of the lathe machine. And now we continue. Now you can see processing of the external surfaces of the workpiece on a screw cutting lathe. It's a cylindrical workpiece, and external surface of this workpiece is cutting on this lathe machine. Different diameters of the workpiece you can see in the figure 3. Basic methods for installing workpieces on the lathe. As usual, we use the chuck to install the workpiece to the lathe. We use chuck installation, mounting in chuck and rear center. It's a chuck 1 and rear center 2. And installation in centers. From the left side we can see center, and from the right side you can see the center 2. And we use clamp and the clamping driving chuck to move to rotate our workpiece on the lathe. In this case, we use clamping chuck, rear center 2, 3 it's detail or workpiece, 4 it's clamp, 5 front center, and driving chuck it's 6 driving chuck. Consequences of insufficient precision of machine components. Schemes for the formation of conical surfaces of the workpiece during processing on a lathe due to its geometric errors. You can see how the geometric errors can be after the cutting. If we have angle alpha that is not equal 0, then we will have the geometric errors. When the cutting angle alpha is not equal 19 degrees, in this case, then we will have geometric errors of the surface of our part. And if we have eccentricity between right center and left center, we have E, and then after cutting we will have geometric errors on the surface of the part. Workbench accuracy control tools. When we control accuracy of the lathe, we use control mandrels, magnetic standard with indicator, its indicator, and magnetic stand. We use with tapered holes and control mandrels with more the taper and control mandrels with tapered holes. Determination of geometric accuracy of machine elements. We start from installing the stand on the machine support. We installing this magnetic stand with indicator on the machine support, like in figure 1 and figure 2 in this slide. You can see the stand magnetic with indicator. And it's the process of installing of the stand on the machine support. It's machine support and it's stand with indicator. And first, what we control in determination of geometric accuracy of machine elements. Please write down in your notes these 3 figures and these sentences. So figure number 2.1 is checking the straightness of the longitudinal movement of the caliper in the horizontal plane. In figure 2, you can see checking the straightness of the longitudinal movement of the caliper in the vertical plane. horizontal plane and vertical plane. In figure 3, you can see checking the one axis of rotation of the spindle of the headstock and the axis of the whole of the tailstock wheel relative to the frame width in the vertical plane. Please write down to your notes these 3 figures. You have the time to do it. Can we change this slide? I see that right.
I have done, teacher.
Okay. I hope Sumia is finished too. Next slide, please. Write down scheme number 4. Checking the radial runout of the centering surface of the headstock spindle for chuck. It's like in this picture. It's determining the radial runout of the spindle set. Write down to your note this figure, figure 2.4. I hope you done this drawing.
Yes, teacher.
we start the next step of determination of geometric accuracy of machine elements. Determining the end runout of the spindle set. Write down to your notes the figure 2.5, checking the end runout of the headstock, spindle, support, shoulder. Its indicator and spindle is rotated like in these photos. The set, magnetic set and indicator, and its headstock of the spindle support. So you should draw this figure into your note. Next stage of determination of geometric accuracy of machine elements, we can see in the next slide. Installing the mandrel in the hole of the machine spindle, we use special mandrel to determine geometric parameters, geometric accuracy of machine elements. And determining the parallelism of the axis of the spindle taper hole. We use the magnetic set and indicator and move support parallel the workpiece or the mandrel, special mandrel. So write down to your notes figure 2.6, checking the radial runout of the taper hole of the spindle of the checked headstock. A at the end and B on the length 200 millimeters. L, its length 200 millimeters. We measuring this parameter in this point and in point on the length 200 millimeters. Of course, when mandrel is rotated. So write down to your notes this draw. Now we have a break for 20 minutes in our lesson. So see you after 20 minutes.
Okay, teacher.
Now, the next stage of determination of geometric accuracy of machine elements you can see in the figure 2.7. Checking the parallelism of the axis of rotation of the spindle of the headstock to the longitudinal movement of the caliper. A in vertical plane and B in the horizontal plane. Please write down to your notes this figure 2.7.